So we're going to do this reproductive hormones and clomiphene degrelix gosrelin. Clomiphene blocks the receptor, estrogen receptor, and it increases the GnRH pulse. So you can see GnRH every 30 minutes. In the follicular stage, it pulses once every 30 minutes. In females, once every 60 to 90 minutes. In the second half, and in the first half, when you have the GnRH pulse of once every like 30 minutes, evidently you can see over here, you're in the follicular stage, and here, you're in the luteal stage. Now, when the GnRH pulse tells the anterior pituitary produce LH-FSH, LH-FSH goes to the ovary produces estrogen, and then here you can see the cycle. Testosterone forms estradiol, estradiol forms estrone, estratriol. Estratriol is the pregnancy estrogen. Estradiol is the regular one, estrone, and estradiol. Testosterone with the help of aromatase becomes estradiol. So testosterone is the first precursor. So if testosterone then becomes dehydrated testosterone in males, which is more potent, and you can see all the drugs blocking it. Here, androstenedione and testosterone are produced, which is inhibited by ketoconazole and danazole, clomiphene. So here, you can see estrogen. Let's look at this differentiation. So you have the X and the Y chromosome, and um, what's interesting is that the paramesonephric or the Mullerian duct forms the internal female genitalia, and the Wolffian duct forms the internal male genitalia, and this happens under the influence of testosterone. And the Mullerian inhibiting factor is produced from, so the Y chromosome has the SRY gene, and SRY gene causes formation of the fetal testis. The fetal testis has Leydig cells and Sertoli cells. And Sertoli cells are the ones that actually produce this thing, and Leydig cells produce testosterone. So spermatogonia are produced from the spermatogonia from the Sertoli. It's just a supportive cell. So if you see the structure of a testis, that becomes more clear. So you can see here seminiferous tubules. Okay, so these are tubules in the testes, and here you can see there are three cells here. One is the spermatogonium. From the morning. So there are three cells, spermatogonia. This will maintain the germ cell pool and produce spermatocytes. They line the seminiferous tubules. Then you have the Sertoli and the Leydig cells. Sertoli cells secrete inhibin B, which inhibit FSH. They secrete androgen binding protein, which maintains the local level of testosterone, produce the Mullerian inhibiting factor in neonates, and tight junctions between Sertoli cells and support and nourish, regulate spermatogenesis, and they produce a sex hormone binding thing, and they convert testosterone. Here, so it lines the seminiferous tubules. These are non-germ cells, convert testosterone and androstenedione to estrogen. Sertoli cells are temperature sensitive, support sperm synthesis, and they inhibit FSH. Because when the Sertoli cells are there, they inhibit FSH. When FSH is inhibited, it inhibits the production of testosterone. So FSH has nothing to do with testosterone in males. FSH instead proliferates the spermatogonia, and uh, here the LH uh, produces testosterone from the Leydig cells. These are in the interstitium, and these are unaffected by temperature. So in a seminiferous tubules, you have Sertoli cells here, you have primary spermatogonia, spermatids and spermatocytes, and Leydig cells. And then testosterone becomes so sexual differentiation. Here you have the undifferentiated infantile gonads. Depending on if it's XY or XX, if it's XY, there will be an SRY, which will then SRY gene will in the Sertoli infantile Sertoli itself will have the Mullerian inhibiting factor, and then the female thing will not develop, and then the Leydig cells of the infant will produce testosterone. The testosterone develops the internal male genitalia, ductus deferens, pubic axillary, penis size, everything, and testosterone will then, with 5 alpha reductase, become dihydrotestosterone and causes the external male genitalia development. In the ovaries, now, if it is female, then the ovaries produce estrogen, and this estrogen causes the external female genitalia development, clitoris, labia, and breast development. Whereas absence of testosterone and absence of Mullerian inhibiting factor by default will produce internal female genitalia fallopian tube, and Sertoli cell shuts down female development. Leydig leads to male sexual differentiation. This is very important because with this we can start predicting each of the developmental disorders. And so the same thing here. So if we go to like disorders of sex hormone, first before that we should touch on puberty, because now we've infantile sexual development. Let's do. So again, this is the undifferentiated baby. Supposing there's a Y chromosome, the Sertoli cells will produce the Mullerian inhibiting factor and block female development, and then the Sertoli cells will then here with the help in the genital tubercle now, and this is the genital tubercle. With dihydrotestosterone forms the glands venous, prostate gland, and scrotum. Estrogen is responsible for female sexual characteristic, and here you have the urogenital sinus, and you have this part. So again, like puberty is, the easy way to think of it is puberty is GnRH driven. So if you have an abnormal GnRH pulse, and then you have a hypothalamic imbalance. So if we have a central precocious puberty, it is increased GnRH, and we can have a peripheral precocious puberty, which is GnRH independent. And if it is GnRH independent, then there will be an external source of sex hormone production, or there will be congenital adrenal hyperplasia, ovarian tumors, Leydig tumors, vacunal bright. If this delayed, again, you can have hypogonadotropic delay. You can have delayed late blooming, Kalman CNS lesion, decreased GnRH. So anything in puberty start with GnRH. It will help you solve the entire thing. and hypergonadotropic hypogonadism. Klinefelter's tonus, gonadal injury. So there's hypogonadism. So it will be increased GnRH and increase hormone production. So always in any puberty or sexual development thing, ask what is happening to GnRH. So let's say each one with GnRH now. So let's say Klinefelter syndrome. What you have here is you'll have a male with an XXY. Now there will be testes, but in Klinefelter's there is no seminiferous tubules, so decrease inhibin B and increase of FSH. So what happens? And there is abnormal Leydig cell function, decrease testosterone and increase LH. So this is abnormal. And then what will be small form testes, tall, statured, because of delayed epiphyseal closures. Gynecomastia female hair may present developmental delay, presence of red, common cause of hypogonadism. So Klinefelter's is like, again you will see the characteristic pubertal development. Tonus is not difficult, but if you go to the other disorders, here you want to see based on the testosterone and its levels. So we should see if the uterus is present and if the breast is absent, or if the uterus is absent and the breast is present. And then we see the genotype. Androgen insensitivity, androgen receptor is missing. A female external genitalia, but uterus and fallopian tube is absent because there is a testis, and they will have a testis. 5 alpha reductase, you will have a male with atypical genitalia. Kallman's will have some smell issues. That's a quick overview.